So, welcome Kuldeep. Welcome Kuldeep to the Happy Sharing series of MLAI committee, and thanks for joining here tonight. And let's get started. So, what we are going to do first is we'll first know what kind of profile Kuldeep is coming from, and to give you the context to the audience, to the MLAI committee. Uh, Kuldeep is heading the AI and growth at VideoKen, and he's the founding member of VideoKen solutions, right? So if you see his profile, he has a good kind of experience coming from his PhD days to building a large scale solution like VideoKen, right? So Kuldeep, thanks for joining us. Can you get started with your journey from your PhD days to the kind of enterprise which you're building right now?
Sure. Thanks, Krishna. I'm glad to be here, and my hello to everyone in MLAI community.
Yeah.
So my journey with data science or machine learning started right from my PhD, where my PhD was in networking systems, but often to solve those problems, we had to apply AI algorithms in various shapes and forms. For example, one of the first problems that I dealt with during my PhD was to SMS spam filtering on mobile devices.
Mm-hmm.
So back in 2011, literally apps were taking off. There were like, the app ecosystem was not as mature as today. So what we wanted to do is you have these all kind of SMS spam coming in, and can you filter them on the devices?
Right.
So that's one of the first project that I worked. And after that, I worked in my PhD itself. I worked on predicting mobility patterns of the people based on their location history. So you try and capture location data of people using cellular data, either through the base station of what cellular tower that you're switching, or the more GPS kind of data, which is you capture it on device. So you capture all this data and then try to predict where a person is going to likely to go next, where a person is likely to go on weekends versus weekdays, right? So those are the kind of things that I have worked on during my PhD. So these are core networking problems, but had a machine learning component inside them.
Yeah, that's actually quite interesting because if I see 10 years back down, and pretty much networking was a field where people were doing a lot of research kind of work. And combination of machine learning with any kind of a discipline is now kind of a famous thing, and that is delivering the results. So I can say that's a very good start, and for the viewers or the people who are in the colleges may take this as that if you are working on some other domain also, there is a good opportunity where you can apply the machine learning algorithms and generate something which is smarter enough version of the existing solutions. Great. So,
absolutely.
Yeah. So Kuldeep, on this front, as you come from the PhD background, right? So many people opt for going to academic side or joining the industry, right? So what was your take on that? So when you completed your PhD, what was your first choice?
Okay, yeah, so it is interesting. So I did give a thought to go to academic life and be a professor. But I think throughout my PhD, I have analyzed that the thing which gave me maximum satisfaction was to see my piece of code impacting people. So whatever piece of code or a system that I was building, how many people that it is impacting in whatever ways and shapes and forms, right? So I thought that being in industry gives me a better probability or a better chance to have that outcome, because that was giving me satisfaction internally that okay, probably it is making some impact, right? So that's why I thought that maybe being in industry would be more favorable to that outcome versus being in academics, because even if you do a very cool work in academics, usually people restrict themselves to just publishing papers or working on more interesting problems rather than big deployments, which is industry is obviously known for doing.
Mostly on the research part, but when you talk about the real kind challenges like scale and other things, maybe those things will be kind of missing in those areas.
Yes.
Right?
Yes.
many times from the MLA community, because we have from beginners to expert level. So we get from beginners a kind of questions like, is this necessary to have a PhD to succeed in a kind of a data science or a machine learning field, or like what's your take on this? So because many times I get this question in community.
Yeah. I mean, again, interesting questions, and I don't think that in today's world PhD is needed to do to succeed in data science or AI field, because a couple of things have picked up. One thing is the whole knowledge has become a commodity. You can learn from Stanford professors, MIT professors, sitting at your home through YouTube, through other open educational resources. So the knowledge is not inside a university boundary. So you don't really need to go to university to learn them. Obviously, you get an ecosystem there. So it's a good enhancement, but not a mandatory requirement to learn something. So people can learn really cool stuff sitting at home. That's one thing.
Right.
The other thing is the whole field has matured a lot. Mm-hmm. So I mean, even in MLAI, there are different kind of roles. Right. So like you have all these frameworks which requires good programming capabilities, good data interpretation capabilities, data analysis capabilities, and for that you don't need to do PhD, right? So you can be a really good developer and pick those frameworks and slowly learn the more mathematical side of algorithms, as opposed to learning it first short and then applying it.
Great.
So deeper dive can happen gradually, as opposed to having a deeper dive first and then applying.
Yeah, makes sense. And when, as you mentioned about the different kind of roles exist in MLAI, okay. And I see that you're leading the AI growth at VideoKen. Can you just give maybe a brief insights on, suppose a college graduate is coming, right? So what all different kind of roles and different kind of things he can pick? Because people are passionate about data science. Okay, data science, being a data scientist, but there are different things also. You can be a data analyst, or you can have a data engineer side, right? Data engineering side, right? Or you can choose to become a kind of an architect on data science side. So what do you suggest that what all different kind of opportunities open for a college students?
Yes, so I believe there are a couple of opportunities here, as you described. One is the data engineer, which is like really the backbone of the whole thing. So I think to me, a role of data engineer is very essential role. I mean, you can't live without that, because overall there's an explosive growth of data. So, and typically a research scientist or a data scientist often is not enough, because he or she can build algorithms on the data, but you really need somebody to run that whole pipeline, right? So and this is, the data has becoming complex. I mean, there are like a lot of people tend to say that 80 to 90% of the time goes really on the wrangling with the data, as opposed to analyzing that data or predicting something, right? So the role of data engineer is very essential in any team today. So you need to learn Docker, you need to learn Kubernetes, there's a Kubeflow, there is a on the compute side there are Hadoop, there are Spark, right? So you need to really learn all this stuff so that you can build any good pipeline. That is one role. Right. And then again, have some basic knowledge about algorithms also, so that you can at least do some baseline work, like putting together logistic regression in the pipeline to start with, right? Then there's a data scientist, of course, which is a cool job that everybody tries to aspire, right? So data scientist is anyway, I think, is pretty much known to everybody. It's they know what they do. And data analyst is, I think, which is more on the product side. I mean, once a product goes live or whatever, right? Then you want to analyze the usage patterns, so that a product manager can make a decision, or a engineering manager can make a decision on what to do next, what feature to build, what are the usage, how the usage picking up, dropping, and all those, right? So I think I see these 3 to 4 roles coming out of this whole story.
Yeah. That's quite a good insight, and I believe now you can explain us like when from after doing your PhD, how you get started in industry, and what make you to start VideoKen, or like how AI has helped you in growing the VideoKen on this front. Yeah.
Sure. So yeah, I mean, I think after my PhD, I joined Xerox Research Labs, where I joined as a research scientist.
Mhm.
And so Xerox Research Lab was like a sister organization of PARC, Palo Alto Research Center,
Right.
which has done fundamental contributions over the year in computer science domain. They have invented mouse, they have invented networking, Ethernet, and all those things. So it is pretty cool to be in the place which has been a forefront of all these computer science inventions over the year.
Right.
I've got to be collaborating with those guys in PARC in California. I met some really wonderful people here in India also.
Great.
So during my Xerox stint, I was working primarily on 2 different kind of projects, and the kind of these research labs function is that you have given a budget every year, and pretty much management tells you, hey, let's do something interesting in these domains. So that's the only, there are no client projects to deal with, or you really work on something which can make an impact on. So you come up with your own problem statement. You need to come up with your own story of how does that fit in the broader picture. So there's a lot of free hand which is given to you, and that does create a lot of interesting stuff. So for example, initial while working in Xerox, we thought that the video indexing is an unsolved problem.
Right.
Specifically the informational video indexing, because there was so much of lecture content available online, even on YouTube, and it is very hard to peer inside that content. Like for example, you have these 20 lectures from Stanford's natural language processing course, and you want to go to the lecture which talk about BERT, right? Now, BERT is not a standalone video in itself, but BERT is discussed on some video on 30th minute. Can you go directly to that point? Right now, it's not possible.
Right.
So those are the kind of problems that we saw in the open domain.
Okay.
And thought that, hey, can we solve those problems? So Xerox experience was very cool in that aspect, that it helped me thinking, how do you think about a problem? And then the solution. First, you try and infer a problem and see how much impact that problem can make on different things.
And that is, I can say, that is the right kind of approach also. When you understand your problem better, you increase your chances to solve it in a better manner using some kind of a first principle, or maybe right kind of a way. So the way you explain it gives an insight to all the developers, all the community members here, that when you get a problem, you should focus on the problem first to understand the complexities, or at least the what kind of motivation behind that problem, or what it will help, and what kind of a basic thing you can go ahead in that direction to solve. So that's a very good insight.
Yes.
So maybe I think that was the reason you moved to VideoKen, and you started VideoKen, right?
Yes. So yeah, I mean it's a evolution inside me also. So while in Xerox, a novel problem to solve was a essential thing to do. That, hey, this is a problem which nobody has solved. Let's start solving it, right? But when we started VideoKen, I think one thing that I need to unlearn was that you think of a novel problem, that's good, but you also need to evaluate the impact or the value that it delivers to your users. They could be your customers, they could be anybody. So you not only assess the problem when you start and picking a problem, but you also assess the value that it will provide beforehand, before you start investing resources inside that.
Right.
right? So that's something that I have learned when I came into a startup, because obviously the resources are always constrained here. You don't have as much funding as you have in a Xerox or any big corporation.
Right.
So you need to really decide whatever you're doing, the project that you're picking, whether they will deliver the right value for your customers. Right. And that could be in customer satisfaction, that could be more in dollars, that could be saving in dollars, it could be anything, but you need to put a second column of value along with the problem.
You should always think about what kind of value your code is generating, and that way you need to plan it in a, because you'll have a limited kind of a budget there, right? So
Absolutely.
that's quite cool. And the kind of problem which you mentioned about the video indexing, right? I see that it has quite huge complexities. So it will be great if you can share us some insights on the kind of the toughest problem which you have solved and which you think that may be useful for anyone to know in the community. So that will the whole purpose of this happy sharing series, where anyone who is watching this maybe will learn the things which is not directly available on some kind of blogs and papers. It's a kind of a unique effort when someone like you or an industry or a company has worked on something, and that is substantial to learn from people like you. So if you have something good which you can share with us, that will be great.
Sure. So yeah, I can walk through our approach. I think with respect to VideoKen indexing, how do we do VideoKen indexing? And this has obviously evolved from multiple years and contribution from many team members. Right. And also something since it has evolved, there are a lot of things which may not be part of today's pipeline, because algorithms are evolving, our approaches are also evolving. But I will take one use case and try and see how does you think of a problem, and then how you go about solving that step by step manner. So right, so I will just present my screen here.
Yeah, Kuldeep. So we are able to see the screen.
Okay.
Yeah, great.
Okay. Thanks, Krishna. So I will go over briefly about what we do at VideoKen and what kind of problems that we are solving and how we are solving them. So I will just take one part of our stack and explain that in detail. Okay, so let's get started. So the motto that we use for us is, we are lighting the black hole of internet using AI. Why we call it as black hole is, today's videos are like black hole on internet, while search engines like Google or Bing does a very good job of indexing text documents. All the videos are left like that. So they only index video title and description, which are basically text. If you see on YouTube, you will see a couple of things there, right? So a search engine will only index title and description of a video, not the content of the video. Right. That's where the search capabilities are very limited. Discovery capabilities are very limited for a videos that you see on internet. Right. So, I mean, why we are interested in this problem? So I will do a bit of problem settings to start with. Videos are going. I mean, I think these slides were prepared before we didn't have this COVID-19 break. So the Zoom's traffic itself has grown. So they have 10x more daily active users now, as opposed to some December, January timeframe. If you talk about VideoKen, we have 12x more traffic than we had in January. So for every video company in this world, this COVID-19 has brought that silver lining, where everything has multiplied multiple times due to people working from home and all of those things. So, I mean, this is a basic thing that I was talking earlier, that the search engines do not see anything. So this is a snapshot of Google structured data testing tool, where there are videos embedded, and then you just pass it to Google testing tool to see what Google can see on this page, and just apart from few title and description meta object.
Yeah.
So and again, I mean, this is again part of the same problem that has been informational videos are really booming up inside enterprises content, the market that we focus on, and like learning, customer events, conferences are picking up now. Conferences are moving digital, so there's a lot of video content being produced, and if you can't index them well, then that video content is not usable enough for somebody to use. So you want to, in general, enhance the usability of your video content. So this is, I will go into more technical now. So we have I mean, VideoKen is a nearly more than 3-year-old company, and initially we started working on this idea when we were in Xerox HSS labs, and then we took it out. We bought licensing rights from Xerox to start our own company. Till now, we have 8 US patents granted on this technology, and nearly a dozen of them are pending. And we have nearly more than 10 top conference publication in top AI conferences. So this is a very
yeah.
So these are so some of these technologies are very grounded. I mean, they have originated from the research, but then again, for a product, we have to really simplify them and make them scale ready, as opposed to working in silos or building a technology which was working for a very small set of videos. So there has been a lot of evolution has taken place over the years.
Right.
So this is, I will give you a very brief overview of what we do. So basically, given any video, any YouTube informational content, and when I say informational, what I mean is something which gives you more information as opposed to entertainment or sports. So like all your learning videos, webinars, customer calls, the meeting that we are having right now, all of these are called informational videos. So we generate 3 kind of indices for each video. One is a table of content, which looks like this. So this appears on your video, and you can quickly jump to any point in the video.
Okay.
So it works like a table of content in a book. So I'm sure none of us have read a book end to end during our engineering or after that, right? So it's very hard. There are a lot of textbooks. So the typical thing that we do is go to the table of content, see which topics that I want to read, and then go to that part or go to that page, right? So we do the same for videos.
Got it.
So another thing that we consider is a phrase cloud, which is a key concepts inside your video content. Like for example, this is equivalent to index words that you have in books, which is saying where on which pages this word is appearing. So in this case, you can look at the phrase cloud and see what, even if I don't show you the video, you can quickly look at the phrase cloud and see what this video is talking about. Okay. Anybody can infer that it's a machine learning video which is talking about terms like supervised learning, unsupervised learning, machine learning, all of those.
Got it.
Third thing is the in-video search, which is basic, which is like if you have a transcript of the video, then you can make it search. You can search for any it's like a control F on your web page. Right. So you can search for any keyword, and then it will show you in the video where it is occurring. So you can see the yellow markers in the bottom part of the screen, which shows where in this video it is occurring. Right. And then you can click on that to go to any point.
Right.
So this is more like a product kind of description, but let's jump right in details. This shows you when you have these indices. So when you have for one video, you have so many indices that you could generate. Overall search efficiency increases multiple fold, because now the videos which only had like title and description have 3 more indices which you can search into. So this shows you the efficiency of that search, considering these additional indices are inside for your video.
All right. Right. So one doubt here. So,
Mm-hmm.
for example, many times what people do as a kind of a hack is they use the softwares where you can generate the transcript for a video and then put that whole transcript into the, maybe suppose if you are on YouTube, then put it on the description part, right? Uh,
Right, right.
Basically, the third phase where you are doing control F to just check where it's coming. Okay. If we add it in the description, right? So it will
Yeah.
be used for the indexing, right? So just
Yes,
to
yes.
understand, I see there are 3 points, right? So
Yep.
definitely the table of content generation is a kind of a big plus, because that way we can quickly jump and defining those table of content also, it's a kind of a, what is a unique proposition. I think I've not seen anyone doing like this actually. Okay,
Yes,
is
yes.
that I can say that is the definitely a quite unique proposition. When it comes to the indexing part, if I compare a performance of putting the transcript into the description and with your solution in ML context, what do you think? Like, where are?
Yes. Yeah. So putting it into a description, putting in the whole transcript and description will definitely help the search engine and getting you the more organic search results for your video or your page or whatever, right? But it does not help user. So for example, even if you do a control F,
Mhm.
the transcript will tell you that, okay, this occurs 5 times in the video, but from a user interface, you can't quickly click on a given point of time and jump to something in the video. You
Yes.
can only search.
Yeah, that is
So
right. Yes.
yeah. So while I mean, we transcript search for us is more like a completeness. That is not something that that I mean, that's more like a part of product package. That
Yeah.
the core problem that we are solving is really you can jump to any point in the
Yeah,
video.
yeah, that is. I don't think that I've seen any place any kind of solutions like this. So let's.
Yes.
I'm
So
very
yeah.
interested in this. Yeah.
Great. So let's jump down right down there. Then so this is our video indexing pipeline broadly looks like. So again, as I told you, it has evolved over the years, and yeah, a lot of things have taken place. So so basically, on the left side, you will see a input video. So you can take any YouTube video, and what we really need is an MP4 file out of that. We don't deal with streaming videos or live streaming or the live calls. We only deal with the videos which are static in nature when you have the full file.
Okay.
Then what happens is that there are 3 things that we kind of do after that. So
Hmm.
one thing is that given any video, I think the first intuition for anybody is to, okay, let me detect frames inside that, right?
Mhm.
Let me see, because that's the visual part in the video. So you can detect frames inside that video content, or you can extract audio, which is like the one thing that you're speaking, right? So you can convert, you can take the audio and you can do a bunch of things on that. So basically, video is composed of 2 visual and audio parts. So basically, you can just dissect that and take them one each as opposed to single thing, single composite entity,
Right.
right? So in this case, for the purpose of this discussion, I would be using more the visual frame processing or visual processing as an example, because just to save time for everybody. But I mean, similar things can be applied on the
Yeah,
audio and
I
all
see
of those
that
things.
is the what is it most interesting part, because how to generate the table of content from a video. I think it's a very good problem to go deep into. Yeah.
Sure, sure, sure. So, I mean, table of content come from both audio as well as visual, but like in this case, I think the way I have narrowed down the problem is that we will only discuss how the table of content is coming from slide-based videos,
Okay, got
right? Right. So, and then similarly, I mean, I can briefly discuss about how it can be done for other kind of videos which do not have slides.
it. Great. Makes sense. Yes.
Okay, so this is what we do. So these are the set of steps that we do, and we'll be getting deeper on each one of these steps in the course of the next slides. So So one thing is that what are the challenges? So when you have defined the problem that, hey, I want to index all the videos which have slides. I have figured out in some way that this is a slide based video. I want to index them. Now, there are a couple of challenges that we have seen over the years. One is the slides gets built up. So there are a lot of people who use animations, right? So for example, if first line will come, then second line will come, the third line will come, and this whole process will take, the full slide to get filled will take like 2 minutes,
right,
in an actual learning video, right? So so what happens in background as a computational processor, right? I mean, if you have to process those videos, a typical video is 30 frames per second, right? So in 1 minute we have 1800 frames,
right.
but the information has not changed drastically in those 3600 frames.
Yes.
Right.
Yes.
You, even if you process 1 frame out of that, and which frame to process is also another question, but then you can save a lot of time, right? That's one thing that so this calls for a significant keyframe detection. Can we try and detect the frames which has maximum information,
Yes.
as opposed to these build up,
Right.
which confuses the algorithm. Now there could be different camera angles within a video. I mean, specifically for conferences, you will see that there will be moving camera here and there. Sometimes it will focus on slides, sometimes it will focus on the speaker, sometimes both of them. So it's very difficult. It becomes difficult from a computational perspective, which frames to pick out of that, right? Can you ignore the one with the human completely or not? So these are the processing aspect that you need to take care of.
Right.
Now then there is a third kind of thing where, even though you will have a lot of visual videos, like a lot of data science kind of videos, which will have slides, then a notebook walkthrough, like a Jupyter notebook, and then there could be a demo, right? So the frames would be different kind of thing. Now you can pick titles from slides, let's say, pretty accurately, because in general text quality is good, but in Jupyter frames and all those things, if you read the code and all of those things, it will make a lot of noise for your algorithms, right? So you may want to ignore those kind of things, not read out code from the slides from the video. Now there are other kind of challenges, like there could be multiple speaker slide format in a video. Sometimes the topic might lie on the top of the slide, or topic could be on the left side, right side. You have seen all kind of designer slides, right? And different shapes and forms. And then there is a presence of objects. So there could be different objects, like a classroom recording will have a blackboard, a slide. It could be have other things in the environment which might confuse your environment.
Right.
So these are the kind of challenges that you have in the real world. VideoKen has processed more than 1 million videos over the years, so we have encountered these challenges as well as a lot of minor challenges also, which are not represented enough to be talking about here.
Yeah.
Okay, so first problem that we faced out was that how do you detect keyframes? So as I told you, right, the frames get built up, the slides get built up. You can start with slide, like for example, in this case, there are 3 boxes, but what happens is the first box comes, then I talk about that, then second box, and the third box. And the whole process will take like a minute. And in that, you will have 1800 frames. Now, it's your job to pick which frame that I want to pick for the processing. Right? So you want to pick, so a general intuition is that you want to pick the frame which has a maximum text onto it.
Yes.
But it may or may not be true sometimes, right? In some cases, you also want to see where there's a break taking place in the text. Like a lot of time, text keeps coming and text keeps going also from the slides. So eventually slide does not change much, right? So those kind of challenges are there. So we have come up with a algorithm which just tries to detect the text, not try to read the text, but try to detect the bounding boxes of the text on a visual frame, which we have trained on a large corpus. And then we try and we did a graph-based algorithm which try and create edges, nodes and edges to see how these slides are moving, how the component on different slides are moving, how much time that they are staying in the slides, like how how much time they're visible, which kind of computes the time that they were there in the slide. So, and then we try and figure out what are the different frames that we can pick. So again, the objective function remains the same, that you want to pick the slide with maximum content into it, and where the slide is pretty much stationary and there's not much inside outside going on.
Right.
So this approach led to nearly 90% reduction in keyframes. Now, if you look at it, right, it is a huge saving, because if you let's say even if you perform for the later part of the processing, if one frame was costing you, let's say 2 seconds, a typical 1 hour video will have, let's say 60 into 60 into 60 into 30, that many frames. And if you cut 90% of the time, that gives you a lot of savings in the compute time.
Right.
Even if you do a good job of filtering the noise, but filtering unwanted information to start with is a very, very good step to do.
Yes.
Specifically in unstructured data processing. That's what it tells you. And I will give you a few examples here. What does it mean that? So this is the few examples, right? This is how the algorithm works. So look at the slides below, the top 2 boxes on the left side where the person is standing. This is how an animation works. So the instructor starts from a very open kind of a slate, but then the text starts appearing one by one for a better learning experience, of course. But for me, as for an algorithm to process, you only are interested in, because the kind of information that you can see is available on the last frame, where the frame might just get changed after that, right? So you want to detect that. That is where this algorithm is very useful to do that.
Right. Makes sense. So one question here. So
yes,
like when you apply this, when you build this, so anytime when we build machine learning algorithms or using deep learning, right, we need to evaluate that how is the performance of this, right? So in this case, when you build something like this, how you make sure that your decision is right or wrong? What is the measure for that?
Right. So I mean, I think there are a couple of things that we can do. I mean, it's not a very simple answer because it will vary across problems. So one thing that you could do is that you could have, I mean, most of the deep learning problems, at least as of today, are supervised, right? So you can evaluate your algorithm's accuracy on a validation and test data sets to figure out how it is doing. But again, it's not possible for us to, like, for example, we can evaluate those on validation and test data set, like for example in this algorithm. But when it is applied in production, the kind of videos that you will see will be very, very different than it was trained on. Right. So you definitely need some way of tracking. So the only thing that we could do was to log things in a very detailed manner, so that a data scientist can take a relook of how things are going. Oh. And a quality analyst can raise from a UI perspective that I think this was not detected as so, because the real world noise might be very, very different than your test and validation data set. That's so even if you're in test and validation data set, you could have a benchmark of 95% accuracy or more than that, but on real world you might have seen unseen frames. So I think in these cases it is always better to have a pipeline ready of reporting these false positives or whatever, and then having them baked into your algorithm for the next release. So that you need to also have that pipeline ready.
Right. Makes sense actually. Yeah.
Yeah. So so this is called this is another algorithm that we have worked on. So this is particularly useful for conferences. This is not useful for like our screencasting here, like, because there's no environmental information.
Right.
Right. But in this case, I will tell you what happens. Let's say even if you have this full frame, the typical our pipeline tries and reads the text out of that. Now, if you look at the second frame here, you will have these the next and all of those things. These will get read by the OCR, and when you try and process the text of the slide, this will confuse the algorithm. Or algorithms are more prone to make any error while picking the title, because it has read a lot of unwanted text which should not be part of your input, right? Because we perform OCR on images. Yes. So one idea could be that, I mean, the same philosophy applies, that you cut the noise as much as possible. Is we try and detect the slide frame. So hey, given this frame, is this full slide, or slide just is the part of this wall frame, right? So this is one algorithm that we have trained with our own data set, where we try and pick the slide portion or the visual portion inside the wall frame. So this is only relevant in some cases like conferences, where or a class recording where the cameraman is recording the full frame, which can include environmental information. This is not relevant for videos where you have webcasting, like the one that we are doing, because it's screen getting captured directly. Right. So this is another thing where we had to do this thing. And again, in your pipeline, you need to take a decision whether to apply this algorithm, apply this processing step or not. So you need to also bake about that fact, right? Whether this is a webcasting recording, or is it a conference recording with environmental information?
Yeah. A very silly question, but what is the full form of FCN based segment?
Fully convolution neural network.
Okay, fully convolution. Okay, got it. Sure. So in this case, okay, got it. So this will be useful for, I think this you can use it for like in this scenario, because it has the objects, different kind of people and other things. Maybe in that kind of scenario, that will be useful, right?
Yes. Okay, so this is the third step, which is basically, once you detect that there's you have detected that there's a frame and there's a visual frame, then you want to decide which kind of visual frame it is. Is it a slide? Is it a demo? Is it a code walkthrough? Because let's say if you don't do this step, for example, you try to read the text from all of these frames that we detected using an OCR, then you will end up reading text from demo, code walkthrough, where only thing that you will be capturing is the variable names, which are not really the concepts. Right? So the part of this whole reason is that you are better off deciding where to read text, as opposed to reading everything and then deciding should I discard it later, right? So this is where we have, this is a classic visual classification problem, where we take a frame and see what kind of frame is this, and we have a couple of categories there, as you can see, right? And we are again use transfer learning here, where an inception at V3 model, it was trained like 1.5 year, 2 year back. And then we transfer learned on our data set. So we have nearly 100K domain specific images, where we have our own data set, where we manually label these frames of different kinds, and then use that to figure out what kind of frame it is. Now, it helps in a couple of cases. Like, for example, if you find that, let's say you had a Python tutorial, you use slides. So we know that you use slides from 0 to 30th minute. And then you had a 20-minute demo or a code walkthrough. Right. So from slides, we can obviously pick the title very, very, very accurately. But I think where there is a demo and code walkthrough, we can at least label with this approach that saying code walkthrough starts from here. So now this is very important information for somebody who is visiting the video. Then you can jump to directly code walkthrough, right, without spending your time on slides, because probably that is the thing that you might be most interested in. Or you can do a search query like, give me a Python a NumPy video which has a demo into it, or a code walkthrough into it, right? So you can do those kind of queries also, because search, as I talked about earlier, the search becomes a lot better when you have these indices attached to your video.
Right. Great. So in this case, as the frame classification is a kind of a problem which is used in, or if I talk about the image classification, for example, that is used in multiple contexts, right? Maybe autonomous car to any of the fields we use it, right? So as I see that with ImageNet data, right? So there are a lot
Yeah.
of pre-trained models also, like ResNet and different kind of models which are available.
Yeah.
Right.
Yeah.
But I see that you have additionally trained it on the different kind of images, and you have used the transfer learning approach, right? So just want
Yes.
to understand, what was your first step when you got this problem, and how you lead to the transfer learning, and or you just started with the transfer learning? What was your
Yeah. No, that's a very good question. So I think the first step was to just take a pre-trained model and apply on your data set and see how it performs. So that gives you a baseline, right? Like for example, if your problem is to just classify objects like cars, dogs, horses, objects, or different kind of like real world objects,
right?
You probably don't need to do any pre-training, any transfer learning,
right?
You can just use a pre-trained model, and that should work. That should that should be the initial kind of thing, right? But I think what was needed for our problem was that while the typically ImageNet trained models does a very good job of identifying the shapes, boundaries, curves. So it kind of learns, the model learns that's how it distinguishes different objects, because the curves that you see on a car is very different than you see on a horse or a dog.
Yes.
Or anything, or a flower, right? So that's what basically these guys learn. ImageNet algorithms learn with respect to the inception net or ResNet and all of those architectures, right? So our because we didn't had a very huge data set to start with initially, so we thought that maybe we use that capability which is already trained on so many millions of images, where a lot of millions of images already had a text component also there, like street signs and all of those, right? So we use that because this guy has already learned how to distinguish between shapes or curves, right? And then we fed into our data, and then we had to experiment with a couple of settings like different unfreezing layer setup and all those things, trying with inception net versus ResNet and all those things. So that's more like a hit and trial kind of mechanism where you have some intuition, but again, you need to just go one by one.
Yes, makes sense. Yes. Good.
Okay. Yeah. So these are kind of examples you will see, right? So these are the first one is a slide. So you need to say the model has to say slide, right? The second is a handwritten, like Khan Academy kind of video, where the model has to say it's a handwritten.
Right.
So that you don't apply OCR here, because if you apply OCR on a handwritten frame, what you will get is only noise. Right. Or a code walkthrough or a demo. So the model distinguishes these different kind of frames in a video. So and ultimately then we apply OCR, right? Then that's the ultimate step that you want to read. Now, since you have done a lot of visual processing over a video, you only have a handful of frames left where you know that these are the good candidates to apply OCR, and try and read text from them, right? That's the because now you want to see, hey, what topics this video talks about. Let me check that. And now there we face the problem that, okay, all of these commercially available. So we didn't do our own OCR because we didn't think that it's the best use of our time, because given that other people were making really good investment and investment as well as accuracy wise, they were really getting better also. So we use commercially available OCR. So we use Azure's OCR, and we tried a couple of them, Google, AWS also. So we picked one of these OCR and try to read text from these frames which we had. Now the problem there is that sometimes the font, due to the different kind of fonts and occlusion or whatnot, you will have OCR making an error.
Right.
Like for example, I getting read as 1, for example, right? There's a lot of basic kind of mistakes that you will see in these kind of commercially available OCR. So that's where we thought that maybe it's a good idea to apply a language model on our side also. So we first apply a dictionary, which kind of converts the commonly available mistakes. Like some of these OCR have different kind of mistakes which are repeated, right? So if you can learn a model or initially start with a dictionary so that you can keep correcting those mistakes. And the second thing would be to apply a more custom specific language model, because you know which kind of video it is, as opposed to sending a one-off frame to Azure and then let it figure out what kind of domain it is. So like for example, if you know that it's a biomedical video, there are some words which are more likely to come as opposed to something else, right? So you can use a domain-specific language model to correct OCR mistakes as a post-processing step. So after this, what we do is we try and do a visual coherency check. The intuition behind this check is that uh, slides tend to be a similar format, like you have seen my slides, right? But typically, titles were on left side or on the top side. Some people might have some different kind of. So this helps you in wherever there is not a significant difference between the usual slide versus the slide caption or the slide title. It helps you in figuring out where there is a hotspot. What is the position which have maximum likelihood of having a title? Because if you understand the structure of the slides, right, it gives you an additional indication.
Yes.
Then there could be slide topic clutter also, like people keep going back and forward, right? I was going there also. So this creates topic clutter, like some topics might be redundant or nearly redundant, or they can appear twice. So you need to just minimize that error to happen. Yeah, so these are kind of things that we do as a post-processing steps to figure out that you have a clean table of contents.
Yeah.
Right. So this is, I think, the whole thing. So this I just discussed it for slide-based videos, but we have different pipelines for non-slide-based videos. Like you have an interview kind of setup here. Like for example, you have been nudging me for different kind of answers, right? Where it's better to rely more on the audio than the visual part, because visually does not have much of knowledge, like our initial part of conversation.
Right.
Where you try and figure out dominant speaker, which speaker is nudging to whom, and try and use that text to figure out the topics, what topic that he's nudging for, right? For a panel discussion, you are better off doing some more text segmentation, right, on the transcript and text summarization on that, as opposed to any visual processing or any more purely auditory processing. Right. So these are the different things that we do. Yeah. I think one of the interesting aspects that we are very, very excited about is that a lot of top AI machine learning conferences have been using VideoKen indexing to power. So like for example, NeurIPS, every year they produce like 500 hours of content, which is these are really top-notch people like Ian Lincoln, Geoff Hinton, Joshua Bengio, Andrew Ng, a lot of like good, very, very good people go and talk about neural network stuff, which are upcoming and all those. Right? So they use us for indexing their algorithms to power them, and a lot of like all that. I think top machine learning conferences are now powered by VideoKen, which is a very good thing. We're very proud of it. Yeah, and they've been using us over the years. So.
Yeah, it's quite good to see the kind of solution which you have explained us, and I can say that like as a learning, if I see when we discussed about the topic of creating table of content from a video, right? Same problem as you explained can be broken down in multiple pieces. You first check for what kind of details are available. For example, going through video frames or audio information or video meta information, and as you explained the whole pipeline, the whole process, right? It's quite interesting for anyone in the community to understand that how you can utilize the different kind of algorithms to solve a specific problem. For example, the problem which you shared for the frame detection, right? It's a kind of a research topic, and people have worked a lot of pre-trained models are also existing, but coming to your context, or maybe if you are using it in our community for one of the problems, there is a possibility that you need to go beyond the pre-trained models, and the way you have labeled the data and use the transfer learning techniques to have the models which can work in your context, that I can say that's quite a good learning. Again, coming to the concepts of the way this is the concept of basically classifying the slides, but again, coming to the concept of what to say, detecting the keyframes, right? That is also has a good potential. I see in the community people are working on NLP side of things, or text classification and text segmentation kind of things. I believe that has quite a good learning from those kind of algorithms where you can define the boundary boxes of the text which is there, and choosing the right maybe a kind of a frame in a video. Uh, that is a masterpiece. Maybe that, because that overall it will help you basically decreasing the overall frames also. But at the same time, it's basically it's a very important call, because if you take that call wrong, there is a chance that your overall accuracy or your overall performance will go for a toss. So, and coming to the OCR, right, as you mentioned, so it's a quite of a good learning. I believe all these topics from full like the FCN you mentioned, or the OCR technique you mentioned, or detecting the meta where the things are more concentrated and it has the more details in the slides, right? So those are quite good, interesting areas. And I believe from the community side of things, this is a kind of a good, what to say, good start for us, where we can, by checking this example, we can find out areas where we can apply similar kind of approaches, and definitely to present in many of the conferences which is listed by VideoKen. Yeah.
Absolutely, absolutely. Yeah, I mean, it was a great discussion, and thanks to you for inviting me and nudging me for all these questions. I really appreciate that. And I mean, we recently, so these are customers, but I think more than that, we have recently released a Chrome extension where the good thing is that some of these table of content will be popping up on your videos when you watch it on YouTube. So specifically, if you are a self-learner and you watch a lot of videos on YouTube, all informational videos, I mean, it will not help you for any songs or movies or sports, but for whatever videos we have over the years, we have indexed millions of videos, and we have recently open sourced all of that indexing for people to use. Earlier, it was only available to use to our customers, but now due to this COVID-19, we thought that given that so many people are investing their time in self-learning, we have open source using a Chrome extension. So there are a lot of videos that we have indexed. So you can install this Chrome extension, and it will help you a lot in navigating through a video and quickly jump into the part that you're most interested in.
Yes, that's quite good. For example, I'll definitely try this, and I will recommend everyone in the community to use this, especially the people who are, because in community we have experts who are building their own videos. Okay, it's a quite of a good extension where people can make, and it will help them also and their viewers also, because you can directly jump into the kind of content you want to basically take care, right?
Sure.
Very good. I will try this definitely on the MLA community videos which we have right now for sure, so that we should utilize this platform to the full manner. And as all the videos of MLA community is the information domain, so I believe that will be kind of a right content for the VideoKen. And we have videos where we have frames and some code walkthrough also, so that way it will help us also to understand the kind of a rich solution which you have built. Yeah, so that's quite
absolutely good. Absolutely, we will happy to help you on that. Yeah.
Great to say this, man. Great discussion here, and I'll say that it was a quite of a good learning, and definitely the kind of concepts which you have touched will help from beginner to expert level, I will say, because many people are not working in depth of what you say image segmentation kind of a problems, or maybe dealing with something like this. Okay, so that's a good learning for the community itself. So I would like to thank for your time, and thanks for coming here and giving us this talk about how we can approach a problem. So thanks a lot, man.
Yeah, thank you, Krishna. Thanks for your time also, and I would love to get any feedback. Please, this is my email ID, and please try our Chrome extension. I will send a different email to you, Krishna, with a link.
Sure, definitely. Yeah.
Yeah.
Thanks
Okay.
a lot.
Thank you.
Thanks.
Thank you.
Thank you. Bye-bye.